Example number 2. If the function f of x equals to summation of x to the n over 2 to the n, where n starts from 0 up to infinity, what will be the radius of convergence for this function? It equals to 1 over 2 to the n times x to the n. 1 over 2 to the n is my a sub n. So apply the ratio test where a sub 1 equals to 1 over 2 to the n. Look, the function f of x equals to summation of x to the n over 2 to the n. We need to find the radius of convergence for this function. How? Can I write 1 over 2 to the n into x to the n? Just separate 1 over 2 to the n here. It is constant, which is a sub n. So my a sub n equals to 1 over 2 to the n, not x to the n. A sub n is 1 over 2 to the n. What will be a sub n plus 1? It will be 1 over 2 to the n plus 1. So apply the ratio test here, which implies that 1 over r equals to limit of 1 over 2 to the n plus 1 or 1 over 2 to the n, where n approaches infinity. Look, according to the ratio test, a sub n is 1 over 2 to the n. Plug in that 1 over 2 to the n here in the denominator. In numerator, we have a sub n plus 1. So a sub n plus 1 equals to 1 over 2 to the n plus 1. For the n, we're going to put n plus 1. So I will plug in 1 over 2 to the n plus 1 in the numerator, which implies that 1 over r equals to limit of 1 over 2 to the n plus 1 into 2 to the n over 1. Bring this 1 over 2 to the n up. If you take this denominator and make its product with the numerator, this 2 to the n goes up and this 1 goes down. So I will have 2 to the n over 1 instead of 1 over 2 to the n after taking product with the numerator. Now I want to cancel this 2 to the n. To cancel this 2 to the n, let me do some modification here in the denominator for this term. Can I write 2 to the n plus 1 equals to 2 to the n times 2 to the 1? Yes. So I can write 2 to the n plus 1 equals to 2 to the n times 2 to the 1. Look, they have the same basis, so their powers will be added. You'll get back the same thing, 2 to the n plus 1. Whether you write 2 to the n plus 1 or 2 to the n times 2 to the 1, it is absolutely one thing. But I did this modification for the purpose because I need to cancel these 2 to the n. Now I can cancel these 2 to the n with the 2 to the n, and I will left only with the 2 in the denominator. So this implies that 1 over r equals to limit of 1 over 2 modulus where n approaches infinity. This 2 to the n cancelled with the 2 to the n. 2 to the 1 is 2. So I will have 1 over 2 times 1. 1 over 2 times 1 is 1 over 2. I will left with 1 over 2 modulus. Now when you apply the limit to any constant number, the same constant number will be the answer. Look, there is no n variable to plug in n equals to infinity. By applying the limit, it is only a constant. So the limit of any constant will be the same constant. Limit of 1 over 2 where n approaches infinity equals to 1 over 2. So 1 over r equals to 1 over 2. When you do the cross multiplication, you will get r equals to 2. So this implies that r equals to 2. There we got the radius of convergence. As I said, 1 over r equals to 1 over 2. Do the cross multiplication. 2 times 1 is 2 and r times 1 is r. So this r is the radius of convergence, which is 2. We got the radius of convergence by applying the ratio test. Now let me check radius r equals to 2 in the complex plane. This is my complex plane with the imaginary axis. This is my real axis. We know that to find radius of convergence, the power series must converge on the circular region. We have this circle with a radius r equals to 2. This is my r sub c, which is radius of convergence. At this point we have 2. So r sub c equals to 2, which is the radius of convergence in the complex plane.